on average, we're seeing about 8 to 10% savings in your energy costs.
You're listening to Smart Thinking, a podcast from WSP. I'm Matthew Marson, taking you on a journey into smart buildings. In this episode, we're talking about heating, ventilation, and air conditioning analytics, or HVAC Analytics for short. Joining me in the studio is MileshPatel, Director of Solutions at Iconics in the UK. Milesh works across all industries, and his speciality is working with real-time data, enriching it with other data sources in an organization and delivering contextually rich, easy-to-maintain dashboards and visualizations. Welcome, Milesh. First question for you. What is a smart building and why should we care?
Hi, Matthew. So for me, a smart building is a building that tells you what it's doing. And that's really important in this day and age where you're thinking about what is the energy consumption that my building is using? How are my employees behaving in terms of their wellness and their productivity? By being able to measure what a building is actually doing, you're able to make adjustments and tweaks and start to optimize the way that the building and, in the end, the occupants are actually behaving.
So what are HVAC analytics and how can you see them helping?
HVAC Analytics is a set of software that sits on top of the existing building systems, plugs into all the various systems that the building has, and starts to pull out trends and patterns and identifies potential issues that are causing any particular problems in terms of your heating or cooling or just in terms of your general occupant wellness. So we're able to take that information and we're able to generate suggestions on how you can tweak and optimize the building behavior.
Okay, have you got any examples?
A really good example that we've got is Deloitte's new headquarters here in New Street Square in London. It's a building that is a flagship for Deloitte, and it incorporates pretty much any and all sensor platforms that you can think of. We're combining occupancy, environmental data, room booking systems, BMS systems, all in order to identify how the building is operating and to be able to tweak and manage how it works across the various floors.
Okay, so does that mean you can do things such as a real-time occupancy adaptation? So let's say, for instance, a meeting room has been booked but nobody actually turns up. Does that mean we can step back some of the energy consumption?
That's exactly what that means. Because we're taking various pieces of information that typically by themselves wouldn't make a lot of sense. But by combining them together, we can very much be more efficient. So we're turning off the air conditioning because after 5 minutes, we can see that there's nobody in the room, even though that room has been booked. Therefore, increasing your energy efficiency.
Okay, so when you start to add it to other things, it becomes much more powerful. But let's consider what at its heart of HVAC analytics. Am I right in thinking that it's essentially a set of energy analytics that looks at all of the different points so you get a glimpse into how individual machines within the building are working, and then also fault detection and diagnostics? So in addition to knowing what the energy is doing and how the machine's behaving, you can then also start to see how bits and pieces within the machine might be deteriorating over time. So it kind of gives you the ability to predict what's going to happen before it actually happens.
Yeah, exactly. So there's a twofold part to that. The energy and the FTD that you're referring to talks about the physical assets in the building. So what are my fan coil units and air handlers and all the various bits of HVAC equipment that are in the building to maintain tenant comfort doing? And by analyzing the performance of those assets using the energy analytics and the fault detection modules, we're able to optimize the maintenance schedule for that and to keep the assets running as efficiently as possible for as long as possible. Tie that into then the rest of the data that comes from things like occupancy and the room booking systems, and you're then able to make multiple optimizations to the building because you've now got access to a vast amount of data that you wouldn't necessarily have had before.
Okay, and what kind of savings are you seeing from successful implementations of this?
Typical savings that we're seeing varies depending on the building, but on average, we're seeing about 8 to 10% savings in your energy costs. And that is by having the solution running for a period of at least a year, you can expect to see those kinds of gains, a process that we call continuous commissioning.
Well, okay. What kind of client issues are you seeing, and how do you think this sort of software helps?
So one of the main issues that we see in typical buildings is the disparate nature of these various systems. every system sits in isolation, doesn't talk to anything else. And, you've got systems that are heating a building at a set schedule because that is, what they're used to. And yet you've got a room booking system which is able to tell you whether half the building is occupied or not. So the fact that those two systems are disconnected from each other, and that's the normal use case, is one of the key issues that we see. So unifying the various data sources across the building is really important.
Could you give me an example of how a client's been able to use HVAC Analytics for business advantage?
So in terms of energy savings, we're doing a lot of work with clients who want to optimize and reduce the costs of their buildings. So we have a governmental client who has energy analytics and fault detection running across multiple facilities. And what they're able to do is review what their energy bill is over the course of a year, look at what optimizations can be made by the software over a period, and from that take really strategic decisions. So in essence, is this building too expensive for us to actually run, even if we're trying to maintain it? In which case, let's not hold this building anymore. So it's making really big strategic decisions on looking after your portfolio based on the energy and the fault detection data that comes out of the system.
Wow, so that's actually really quite powerful for an organisation and the sorts of savings that they can deliver for a business. It's incredible. Quick question for you then. If you were an organisation that wanted to deploy HVAC Analytics across your buildings, what would the top tips be?
For me, the top tips would be think about integration, think about making sure that you have the sensor data that you need and it's available in an open platform. We talk a lot about building standards, and a lot of the new buildings tend to use all of the standards. A lot of the old buildings don't have that. And it's really important to try and make sure that your data is available in an open way so that you can have multiple tools extract that data and make use of the data rather than it being locked up, in your BMS system or in any of the other systems that you've got. So open connectivity and integration is the key takeaway that I would have.
A big thank you to MileshPatel, Director of Solutions at Iconics in the UK. In our next episode, we prove smart lighting isn't just about occupancy sensors. Jay Ratton wows us with the benefits of its bidirectional communication and how lighting is the key to unlocking a building's smart potential.
If something in this episode has piqued your interest, then have a chat with us. Email smart@wsp.com.
You've been listening to Smart Thinking, a podcast from WSP. I'm Matthew Marson, and thanks for listening.